Okay, I'm recording now. So the water supply fixture unit, we know what this is. It's just a measure to quantify the amount of water that we have in each fixture. We have toilets, sinks, and that's it. Um, the sole purpose of a fixture unit concept is to make it possible to calculate the design load on a system composed on different types of fixtures, each having different flow rates. So yeah, this is the idea. We have different flow rates. The flow rate is the amount of water that goes out from any fixture divided by the time. Okay, so we have two things. We have the amount of water, liters, gallons, or whatever, and we have to divide it by time. This is the flow rate. It's not the same 1 gallon per minute than 1 gallon per second. Okay, it's 1 gallon, but the flow rate is different. So for fixtures, we have different volume and we have different times. So that's why we have the concept of a water supply fixture unit. And what else? Well, then I told you that there are rules of thumb, up to 3.5 inch branches. We need a 3/4 inch main. And I did this. Okay, so here we have different fixture units. And here, if we have a 1, 2, 3, 4, 5, 6 half, we need 1 inch. This branch should be 1 inch. If we only have 1, 2, 3 half, we need the 3/4. Okay, so this is the rule of thumb. And remember that we need two different piping systems for the cold and the hot water. Okay, so we are calculating only the cold water. Why? Because the hot water should be the same. Well, it's the same. There are differences because toilets don't have hot water, but for sinks, showers, bathtubs, lavatories, showers, whatever, we always have cold and hot water. So if you know how to calculate the water supply, the cold water supply, you will know how to calculate the hot water supply. So we're just designing the cold water supply. And then there are different tables. Okay, so we have to use this table to find out the water fixture units. So this is the water supply fixture units, WSFU. And we have for cold water and hot water. And here we have a list of fixtures. We have bathtubs, bidet, uh, washer, dishwasher, drinking fountain. We do have drinking fountains in the TDS center. I think there's a drinking fountain. Yeah, so those are two drinking fountains. Okay, I didn't, when I calculated that, I didn't take the drinking fountain into account, but well, it's just an example. So here we have a list of things. So first, we need to count how many fixtures we have. Okay, so if we focus on the men's restroom, I told you that I'm not doing the drinking fountains here. So there are 1, 2, 3 toilets. Let me write it down. 3 toilets. We have 2 urinals and 1, 2, 3, 4 sinks. Okay, so this is it. And now we need to go to this table. And on this table, we have 2 different pieces of information. We have the fixture units, and we have the minimum size for each device. Okay, most of them are half inch, as you can see. But for example, a urinal in a public building with a flush valve, we need 1 inch. If it's a flush tank, we have half inches, and we have a flush valve, but it's a private one. It's 3/4. I don't mind. You can do whatever you feel like. Since we have two urinals here, I think I have decided for that example that we're going to use this one, the public flush tank, and then for the urinals, the pipe should be ½ inch. I have decided on that one. Okay. And then the water supply fixture units is this column. So for urinal, it's 3, I think. Yeah, so it's 3. Water supply fixture units. What about the toilet? The toilet is a water closet. So the water closet, it's let's say a public building, and we have the flush valve and the flush tank. I don't know. Let's select this. I have selected this because it's the thinnest one. That well, this is just an example. Okay, so we have toilets, and the toilets it's 3/8. You see this branch. So the pipe attached to the toilet has to be 3/8, and then the water supply fixture unit is no, yeah, it's 5. So it's each one it's 5 water supply fixture unit. Okay, and then we have the sinks. Where is it? Lavatory. This is lavatory. We have a dishwasher, bathtubs. We can use either the lavatory or the service sink. I don't mind. So let's use this one. It's a public building. Yeah. So this is a half. You see that the branch is half. So the 4 sinks, we have 1/2 inches. And the water supply fixture units is for cold water is 2 1/4. Okay. So this is it. With this table, we need 2 columns. We need this column here, the minimum branch pipe size in inches, this column. And then we need the, if we are calculating the cold water, if we were calculating the hot water, we would need both. But since we are calculating only the water supply, the cold water, yes, we need to work with this column. Okay. Why have I decided if it's a, well, it's a public building, that's for sure. And then what about the flush valve and the flush tank? I don't know. Well, that depends. It depends. So we can see if we want to save water, we have to look at the water fixture units, and we would decide the lowest value if we want to save water. If we are not concerned about water, and I don't think in New Hampshire you have these water concerns because there's plenty of water. I think those are flash valves because you don't have a tank. I don't think there are tanks in at least in the TDS center. I tend to use the smallest one because I come from Spain. In Spain, we are always saving water because we have drafts some from time to time. But if you are not worried about water, you can use the one with the flash valve. It's up to you. I don't mind. Okay, but now we have made those decisions, and now we have to abide by those decisions. Okay, so I'm sharing that screen now, and there were 3 toilets. There were 2 urinals, 4 sinks. Okay, and this was the branch size and the amount of the water supply fixture units. So if you remember, there were toilets here, 1, 2, 3, 4, a urinal here, 1, 2, and then there are 4 sinks here. This is the restroom. Okay, so now we have to supply water to all those pipes. So if we are supplying cold water, we can use a blue color. Okay, so what we have calculated, or we have looked at the table, is the branch of each fixture. So for sinks, this is 1/2. So that would be 1/2. That would be half. That would be a half, and that would be a half. Okay. What about the toilets? The toilet is 3/8, 3/8, and 3/8. And what about the urinals? It's again half. Okay. And that's it. Can we write down the water fixture units? Yes, we can. So this is each toilet is 5 water fixture unit. Each urinal is 3, and each sink is 2 1/4. Okay, so this is the information that we need. And then if we go to the rule of thumb, you remember that if we had okay, now you see that screen with the rule of thumb. Okay, so up to 3 1/2 inch branches can be served by a 3/4 inch main. Okay, so up to 3 3/4 or up to 6 1/2 inch branches can be served by a 1 inch main. And up to 5 3/4 or up to 10 half branches can be served by a 1/4 inch main. Okay, so this is the rule of thumb. So up to 5 3/4 or up to 10 half inch branches. So now we have to look at what we have here. Okay, so up to 3 1/2 inch, we could use a 3/4 half. But here, if you look at the sinks here, we have 1 2 3 4. Okay, so this one, if we are working with the blue, let's make it thicker. So this pipe here should be 1 inch. It can't be 3/4 because 3/4 is only for 3 1/2 inch fixtures. Okay, if we have 4, 1 inch is fine. Then we go this way, and there might be another branch here. Okay, so what is the size of this branch? Well, the rule of thumb says that up to 5 3/4 or up to 10 1/2, we need 1/4 inch. So this is what the rule of thumb says. So this is either this, or it's not and, it's or. Either this or 10 1/2 inch. Here we have 1, 2, 3 3/8, and we have 2 1/2. So I think that goes well. So we don't have to be. I mean, we don't have 5 3/4. We have 3 3/8 and 2 1/2. So I think this is the case. So I would say that this is 1/4 inches. Okay. So that's it. We have calculated the water supply fixture units. We have calculated this value, the branch or the pipe size that each fixture needs. And then we have calculated the main branches here. We have to calculate something more. We have to calculate this part, because here we have this, as of here, we have to connect this branch and this branch. And okay, let's work with another. Okay, okay. So we were working. This is the ladies. This is the men's restroom. So we have a branch here, and then we have this branch with toilets. And here we have the branch with the urinals, 1, 2, and 3, 1, 2, and 3 toilets. That was 1/4. Here, that was 1 inch. Okay. So what about what happens here? So here we are connecting 1 inch and 1/4. This is not 2 1/4. So usually when we are connecting 2 branches, we can move to the next one. So I would say that this is 1/2 inches. Okay, because we have connected this one 1/4. So here in this connection, this pipe is 1/2. This is what I would say. Now we can either have another branch for the ladies' toilet, and then there will be toilets and sinks, whatever we have here, and then we can calculate this again. And now we have to check. Okay, so common sense, I would say that this is fine. We can place this 1/2 pipe and it will work. But now we have to check whether this is right or wrong. So remember that I told you that this can be 1/2, but now we have to check. And to check this, we need to understand where that water pipe comes from. So that water pipe comes from outside. Okay, so we have the building, and here we have the city water supply. Where does it come from? Well, I don't know, but when I walk to the TDS center, there are always people fixing something in the parking lot between the parking lot. It's not the big parking lot that is facing campus. It's the parking lot facing, this is north, south, east. I don't know the name of that parking lot. Anyway, I always see that there's a truck doing something. So I bet that all the water supplies, the gas supplies, and every supply that comes to the campus goes to that place. Okay, so we can imagine that in the TDS center, we have the water supply point here somewhere. And then we go into the building, into the TDS center. So this is the branch that I told you that it's 10 feet. Okay. Then we go up. Okay. So when we are inside the TDS center, we have to go up, and we have the first floor, and then we have the second floor. So we have to calculate the maximum distance from this water supply, okay, from this point until the last fixture that we are calculating. So the last fixture is not on the first floor, it's on the second floor. So on the second floor, then we go that way. I told you that this was 10 feet. And then here we have the sinks, 1, 2, 3, and 4. Those are the sinks. And then we go here. We have 3 toilets. And here we have 2 urinals. Okay, so what is the maximum length from this point? This is point A. So what is the farthest point? This point, point B. So what is the length from point A to point B? It's 10 feet. This branch is 10 feet. I told you that this is 12 feet. This is 30 feet. And then we need to go up. So what is the total height of this building? Let's say 30 feet. I'm making up figures, but it's something that can be, okay? So from the entrance of the entrance to the building until we go up, we can have 10 feet. Then we go up 30 feet, 2 floors. I think this is accurate because each floor it's like 15 feet. So yeah, so we have to go up 30 feet. Then we go this way 10 feet, and we have the first branch for the sinks, and then we have the second branch for the toilets. And I think this distance it's around 30 feet as well. Okay, so distance from A to B is 10 plus 30 plus 10 plus 12 plus 30. Okay, so this is 30, 30, 60, 70, 80, 92 feet. Those are feet. Okay, so this is the maximum distance from the supply. This is the water supply point. And why is this point? Because here we will have a water pump. Okay, so we have to pump water from this point up to the farthest toilet. Do we have any other toilet in the building? Yes, we do. But is it supplied by this water pump? I know that there are toilets in the other part of the building where the studio is or close to the computer lab. But I don't know if we will have this pump or there will be another supply point in the other part of the building. I don't know. But if there were another, if we had only this water supply point, then we will have to move all the way up to the last toilet or the last sink that we might find in our building. Okay, so this is about design. So we can design if this is a TDS building. If this is the building with the, I don't know, this is something like that. This is the lobby. Okay, so this is the parking lot that I was, and this is the men's, and this is the ladies. So I'm assuming that, I'm assuming that there's a water supply there's a city water supply that runs underneath the Winchester Street, and then we have a branch here, and this then as of this point, it's a King State property. Okay, so that belongs to the municipality, but as of this point, it belongs to the to King State College. So if there's a restroom here and there's another restroom there for men and ladies, I don't know. So we can assume that we have this branch here, and then we supply this to the men, and then we supply this to the ladies' restroom, and there might be another supply point here, and then we supply this to this. Or if this is the only supply point, then we have to go all this way to supply to those restrooms here. And then the farthest point would be this one. Okay, not that one. But it depends. I don't know. I haven't studied the TDS, so I'm assuming that we have this layout. Okay, so here we have the supply point, and then we are calculating only the circuit, but it might be different. When we have long buildings, I think it's a good idea having two different supply points, but it depends. Okay, so let's assume that we are only calculating this part. Okay, so we have to keep in mind that we have this thing, and these are, yep, the water fixtures. Okay, so we have 3, 3, 5, 5, 5, and all these, because we need to know the total water supply fixture units that we have. Okay, so what is the total? It's 1, 2, 3, 15 plus 9, 24 plus 2 1/4. I need a calculator to do this. 2.25 times 4. This is 9 plus 24. This is 33. Okay, so the total water supply fixture units is 33. So we can come back here. $33. So this is the distance between the supply until the farthest point fixture. In this case is this toilet here. It's 92 feet. We need the total water supply fixture units. It's 33. And now we need the maximum height that we have to, yeah, so we need to know the height between the supply point and the last toilet. So in this case, we have to go up 30 feet. Okay, so the height is 30 feet. Okay, so we need these three data to complete the exercise now. We need the maximum length from the supply point until the farthest. We need the height. So we have to go to the second floor. So this height is 30. And then we need the total water supply fixture units that we have in this layout. So in this, we have 33, adding the toilets, urinals, and sinks. So those are the three numbers, the three figures I need. And now I have to share the screen because we need to go to this point here. Okay, so let's delete this. Well, do not delete that. Okay, so now these are the instructions. First, we need the minimum service water pressure for the location of construction. Usually, this is available through the municipal water department. Well, I found out because I did the same thing last year. So the minimum service water pressure in Kim is 65 psi. What does psi stand for? It's pounds per square inch. Okay, so this is pound per square inch. This is what PSI stands for, pound per square inch. And why? Well, the municipality, they have to supply pressure, okay? Because if we are working with a single family house with no more than 2 floors, so that should be enough. We don't have to spend money on a water pump. Anyway, it's useful, or so it's a good thing having a water pump, even if we don't need it, because if there's a problem with the water supply, with the municipality water supply, then we have our own water pump in our building. Okay, but they are committed to supplying this pressure to our buildings. Okay, so this is I mean, it depends. It's not the same in every single city, but well, it's something feasible. So we need this 65 pound per each square. Then we have to compute the total WSFUs. So our total was, you remember, was 33. Okay, because we had 3 toilets, 2 urinals, 4 sinks. So the total water supply fixture units, it's 33. Then we need to calculate the maximum developed length of the water piping. And we have to multiply this by 1.2. Why? Just in case, because we have elbows, we have T's, we have valves, okay? So we tend to multiply this by 1.2, okay? So it's not just calculating the length from the water supply to the farthest point, but then we multiply this by 1.2. So in our case, it was 92 feet multiplied by 1.2. So the total is 110.4 yeah, 0.4 feet. Okay. Okay, so that's it. We need to calculate the length. It was 22 times 1.2, so it's 110. And now we have to compute the static head. So this is the pressure loss from elevation, and we have to subtract it from the surface water pressure. Okay, so the surface water pressure is 65. And then, well, this pressure loss is found by multiplying the vertical height. The vertical height, you remember, was 30 inches. We have to multiply this by 0.433. Okay, so in this case, it's 12.99. That means that we wouldn't need a water pump, because if we are working with a high-rise building, if this number is higher than 65, then we need a water pump because we don't have enough pressure. Since this number is below or is not as, yeah, it's under this 65, we don't need a water pump because the water supply that we have from the municipality is enough. But we have to take into account that we have this low pressure loss because of the height, okay? So we need to calculate the maximum height. If we are working with the second floor, they should be 30. Then we have to multiply this times 0.433. And this is the pressure loss. We have to subtract the pressure loss from the water pressure, the surface water pressure that we have from the municipality. Okay, so this happens to be 52. This method is working for, well, it's not a high-rise building. Okay, so what would be the maximum height of this? Let's say 5 floors. Okay, as of 5, 6 floors, we need to provide the building with a water pump. Okay, but for single family houses, I think all our campus buildings are less than 6 floors. I think so. At least the TDS center is just 2 floors. So this can work for that building. Okay, so it's quite easy. This is always 65. Then we need to compute the water supply fixture units. So we have to add all our fixtures up, and this is the total. Then we need to measure the length. And once we measure the length from the supply until the farthest point, then we multiply by 1.2, and that's it. And finally, we have to compute the static head, or the static pressure loss. And that depends on the height. Okay, and then we have to subtract this number from the water pressure, the supply or the surface water pressure. And finally, we have to use table 13.10 to determine the minimum pipe sizing based on this demand. And then we have to compare this number with what we have, with the rule of thumb. Okay, so this is just to check if what we have done is good or not. So let's do it. This is the table, the maximum. Okay, so this is the table that we have to use. Here we have the supply pressure. Here we have the maximum developed length, and these are the numbers that we have to calculate or to find out now. So first, the supply pressure. So what is the supply pressure? This number, it's 52. Okay, so it's the surface water pressure minus the pressure loss that we have. So the result is 52. If we go here, we have 3 tables. We have these from 30 to 45, from 45 to 60, and over 60. So if our result is 52, so we are in this table. Okay, so this is, we are looking for, we are studying only these values. So we don't need this, we don't need that. So let's make this clear. Okay, just because we are between 45 and 60 PSIs, then we are in this part of the table. Then the second is the maximum length. So the maximum length was 110. 110.4 feet. Okay, so in this table, we have to go up. So it's not 100, it has to be 150. Because if we are between 100 and 150, we take 150. So we are in this column. Okay, so now that we have, we are in this table. Now we have to work in this column. And finally, we have to select the fixtures, the water. The fixture, the water supply fixture units. It's 33. Okay, so in this column, we have to find the 33 value, This is 30, so this is not the right one. We have to go to the following one because we don't have 33. So we always have to go to the following one. So in this case, it's 52. So in this row, we go leftwards, and the building supply branch should be 1/1/2. Okay. So I have to go back to the okay. I go back to this, and if you remember, we had this 1/4, and this had to be 1 inch. I told you that this first branch here should be at least 1/1/2, at least. Okay, so we have to compare this value with what we have here, and I think it makes sense. Okay, there you go. What we did is this branch, I think it has to be 1/4. This branch had to be only 1 inch. And we are looking for this one. So this one has to be 1/1/2. Which makes sense because if we are connecting this 1 inch branch and this 1/1/4, this has to be bigger. So at least it has to be 1/1/2. So is it clear what we have done? So I'll go over it again. So we are working with this. Okay, so we have the main supply. So this is the first floor. This is the second floor. So we have this. This is the water supply. Okay, so here we have 3 toilets, 1, 2, 3, 2 urinals, 1 and 2, and 4 sinks, 1, 2, 3, and 4. We have the same on the first floor, but we're not calculating the first floor now. So we have already calculated the water supply fixture units. We had calculated this pipe. So this pipe was 1/4 inches. So this pipe was 1 inch, and we have calculated that this one is 1/1/2. And I think we are done. Well, we are done, but now I want to explain you a couple of things before moving to your own exercise. So this is what I need. At the end, I need a drawing, yeah, something like that. Okay, so you can use the layout. You have the plan of the ladies' restroom, and we can have exactly the same supply, and then this segment is the same, the height is the same, and then you need to let me know. So imagine that we have this is the ladies' restroom, the layout of this part of this piping system. Okay, but this first branch 10 and this second branch, the height of 30, it can be the same. Then you have to go that way, and then you have to prepare something, the same thing I have done here, but with the ladies' restroom. And what do I need? Well, you remember that this was 3/8 because it was for the toilets. That was a half because it was for the urinals. That was 1/2 because it was for the sinks. And then we need this branch here, 1 inch. This branch here, 1/4, and finally this branch, 1/2. But first I want to go over this. So I will try to explain a detail. For example, if we're working with the supply, I told you that if the surface water pressure that we receive from the municipality is enough, we wouldn't need we don't need a water pump, but it's always recommendable having a water pump just in case. Okay, so imagine that the supply from the municipality comes from Winchester Street. Okay, and if you look at the floor, I'm sure that you will find something like that. It's a pit. It can be round or rectangular or square, but I'm sure that if you look at the entrance to the TDS building, we will find like we have a metallic tap here, and people remove that, and most likely there will be a water pump here, most likely. So if we look at this, so that is the limit between the municipality and my own building. And we only have something like that. What is this? This is a water pump. And this is a valve. And this is another valve. When there's a water pump, and it's something important, it's not just a water pump, it's for the, I don't know. But if it's a water supply, it's something important. We have these two valves because if there's something, if there's a leak or there's a problem, we just cut off this circuit, and then we remove this water pump, and then we place another water pump, and then we open those valves again. Okay. Sometimes, if it's really important, we can have like a bypass, and there is another water pump here. Why? Imagine that this water pump collapses. So after, because we have a service life for all these devices. So imagine that it's only for 5,000 or 50,000 hours. So after 50,000 hours, this pump will collapse, and then we have to replace it. If we have this bypass, we can cut off this one, this circuit, we can open this circuit, and then this water pump immediately start working, and then we can remove this one, and then we can replace it. And then we have another supply for, let's say, 50,000 hours. Okay, so usually when we have a building in which we don't want to cut off the water supply, we always have these two water pumps in parallel. Only one of them is working, so this valve is closed and this valve is closed, so the water goes this way. But if there's a problem with this water pump, we cut off this, and then the water supply goes this way. Okay, so you will see that in many mechanical rooms, you will have like two parallel water pumps. Why? Because we consider that it's something important, and we don't want uh, to cut off the water supply of that building. And in public buildings, we have this. In single family houses, I don't think we have two pumps like this. I don't know, it's not usual, but I think we should have, because what if we don't have water in our single family house? Immediately we notice that, and we just give a call to the plumber. Okay, I don't have any water in my bathroom. You complain, and then the plumber comes. They charge you $1,000, and then they replace the water pump. If we had two, we wouldn't notice that we are run out of water. Okay, so I always recommend having two water pumps, but they are expensive, so we have to deal with our client. And then when we are supplying water to the fixture, okay, imagine that we have a toilet here. I told you that the water supply usually, I recommend you do it from above. Okay, so before entering the toilet itself, we have another valve here. So that if we have a problem with this toilet, we just cut off this valve, and then we can replace the toilet, and then we can open this valve again. If we are working with the toilet, then with the sink, so every single element has a cut-off valve here. So if we have to remove this, we can do it without affecting. But if we have different spaces, okay, so I will use another drawing. So let's say that here we have a restroom. This is the kitchen. We have different rooms here, and there's another restroom there. How would I, and this is the water supply. Okay, so the first water pump in our house or our building will be here. So now we have to distribute this. We have three places in which we need water supply. We have the kitchen, restroom 1, and restroom 2. So there are two ways to do this. So we can go like this. We can go first to restroom 1, then to restroom 2, and finally to the kitchen. I don't recommend you do this because if there's a problem in the kitchen, I have to cut off the water supply for everything. If there's a problem for restroom 2, and I have this kind of layout, then yeah, I have to cancel the water supply here, and I don't have water in this restroom, or I don't have water in the kitchen. So I wouldn't do that. So if we are having something like that, it's always good having different branches and different valves here and here. Okay, so that if there's a problem in the kitchen, I have this valve and I don't affect the two restrooms. If I have a problem in this restroom, I have this valve and it doesn't affect the rest of the rooms. If we are not good at doing this, it's very usual that you can see in single family houses, we have the supply. And here, this is the first, this is the kitchen. And here in the kitchen, we have this, and then we go to the bathroom. And in the bathroom, we have the shower, whatever, and finally we go to the last bathroom. Okay, and we don't have any. So if there's a problem here, I need to cut off the supply here in this point. So it's always better having different branches. Okay, so this, I can cut off this and it affects only the kitchen. And then I can shut this valve and then it affects only this bathroom. And then I can do this. And if I place a valve here, it affects only this bathroom. Okay, so that's the difference between a linear layout and a branch layout. So this is always better. Uh, so that's it. There is nothing else to know about the piping systems. Um, we are not working with huge buildings. I mean, high-rise buildings. In high-rise buildings, this is completely different, and we need different columns, and we have sectors. So probably we have different water pumps for each sector. Okay, so if we're dealing with a high-rise building, I don't know, with 50 floors or more. Okay, the best option is to divide building into sectors. Okay, so I'm working with this sector, then we're working with this sector, then we're working with this, and then we're working with that. And we have mechanical rooms, so we can have a mechanical room here, another mechanical room there, and another mechanical room there. Okay, so what I'm doing is that I'm considering like 1, 2, 3, 4 small buildings. Let's say like 6 floors each. Okay, and now I'm dividing the problem, and then I have different supplies. So I have a supply circuit for this mechanical room. I have another supply circuit for this mechanical room, and then I have another supply circuit for this one. And finally, for sure, I have the first, because the first mechanical room can be here. Okay, and now from this point, now I can work with a supply for each floor. Okay, so what I'm doing is dividing the problem. If I have a problem in this sector, okay, so only this sector will be affected. The rest of the building can keep on working. So that's why we have separate water supplies, and we have even separate mechanical rooms. Okay, so that would be a high-rise building. If the building, it's not a high-rise building, but it's very long, so we can have only 2 floors. But it's a very long building. I would divide the building in sectors like this. So I would have my own supply for this sector, another supply for this sector, and another supply for this sector. So I think this is what happens in the TDS center, but I don't know. But I would do this again. If we have a problem here, we cancel this sector, but the rest of the building can work. And this is for everything. It's for piping. This is for the mechanical systems. It's for everything. When we're working with large buildings, we have to divide the building, and then we divide the problem. Okay, so if there's a problem, I don't have to address the problem in the high-rise building. I have to address the problem only in the second sector. Okay, so what's the problem here? Okay, so let's solve the problem that we have in this sector of the building, and the rest of the building will work just fine. Okay, so you have like 30 minutes to complete this, if we open the assignment, okay, so first you have to draw the layout. So the main supply will be here. Okay, so this is 10 feet. And then from this point, I don't know, you can go here to the sinks and then to the toilets, or you can have two branches, one branch for the sinks and another branch for the toilets. It's up to you. I mean, there is not a better solution. There is not, okay, no, you have to go this way and only this way. No, you can do it in different ways, but let's try. Then you have to calculate the water fixture units of each fixture here. You have to add them up, and then you have to calculate at least the branch for the toilets, another branch for the sinks, and then you have to check the final branch from the supply. And you can use this to calculate the fixture units, and then you need this table. So depending on this supply pressure, depending on the maximum length, and depending on the amount of fixture units, then you will have to calculate this value. But look at this, the minimum value it's a ½ inch, and the maximum value, even with 500 fixture units, it's 2 inches. Okay, so even if we make a mistake, the mistake is about 1 inch or ½ inch, so it's not. So when in doubt, 2 inches. Yeah, I think this is the summary of this lesson. 2 inches might seem, well, it's too much. We need 500 water supply fixture units. But everything that it's from 1, 1/2, 1/3, it's fine. Okay, so, but I want you to do it, and I want you to let me know. So circle one of these options, then circle what column we are working with, and then circle the one with the fixture units. Then you have to go leftwards, and this is the final result for the main supply pipe that you have to calculate. Go ahead and let me know if you have any questions. So I'm going to stop recording.